I would start right away, and I always like it to make a step back, that we're all on the same page, and be sure that everybody understands, uh, of course, what is generative AI. I'm sure everybody knows it, but I like to always make a step back. And we're having, of course, I'm taking ChatGPT or OpenAI, so I always like to ask the audience who is using it, and please put your hand up who's using it, just to see, because I'm always seeing more hands, and that really makes me happy too. All right, so there's almost all the hands up, so we're almost in. Let's say we're having here the foundation model presented with the algorithm, and this is, let's say, ChatGPT, or let's say OpenAI or GPT-4. What's happening here, of course, it's already a model that's been trained, it's ready to use. So what can you do? I'm having here the first step you can do with it. You can do the prompting with it. And for me, the prompting is like making sure you're coaching your model. So you're making sure that you're telling him you should do this and this and this. In this example, I'm trying to prompt it for sayings. So I'm going to say him, for example, give him two things: better later than never, and no pain, no gain. So I'm going to say him better later, and then he should answer than never. So I'm putting this as an answer. Then no pain, and then as an answer, no gain. So he's understanding, aha, now I need to go in that direction. So this is going to be the prompting I'm inputting. So we're talking here about prompt engineering. Of course, we're talking about text here. We're not talking about video, image, or code, or audio, but it's just a text example. Now I'm going to answer, or I'm going to put the question, an apple a day. It's going to go through this LLM. And of course, he's been reading a lot of books. He's been understanding what is happening here. Let's take here GPT-4, for example. And then it goes further. It understands that it should answer in a certain way. And it's going to answer, keeps the doctor away, because it understands it should take this part here. So it's making predictions and understanding. In most of the cases, keeps the doctor away is the best answer here. But he's trying to be smarter, and he's going to say here, what about a banana a day? A new study shows eating banana helps to prevent and the development of diabetes too. So this is just to show you we're on the same page. We're understanding what prompting means. We're understanding what his foundation model is. Now we're going to make another, let's say, a step more. We're wanting to enhance our large language model. So the first thing I was showing you before is the prompting. So this is the least complex of the three methods I'm going to show here. You're using the core knowledge of your LLM, so you're not using something else. Could be that your model has been trained till 2021, so you're using only that information. That means you can't also really find the exact source of the answer. So of course, it's costly, not too expensive. It's not too complex to build. And the quality is maybe not the best, because it could be that you have answers that are after 2021. Then we have the RAG part. That's the core topic of today. It's going to use external data sets, so you can take your own data that you have in a company. That's the interesting thing, because you have a new context. You can make the response better as in the prompt part. It's much easier to find exactly where the source comes from. It's also always good. And you're going to use vector embeddings, vector database. And this is something, of course, we're going to make a little more deep dive on today. So it's going to be a little more costly, a little more complex, but the quality is going to be much better. Then you're going to have the last one. So this is the parameter efficient fine-tuning, the PEFT. If you're comparing it to the three methods, it's the most difficult one to go for. You need a high quality data set, and you need more performance, compute performance to train this kind of model here. So you see from the left to the right, it's getting more and more complex. It costs more, but the quality is getting better here. This is to quickly circle on the key points of RAG. So the history is, it goes back to the 1970s. The first question of it was question and answering systems. Maybe not very interesting, the name. And in the beginning, it was used for baseball. Then in 2020, you had a guy who was called Patrick Lewis, and he wrote a paper with his team about RAGs. He didn't like this retrieval augmented generation name he was trying to give it, but his team couldn't find a better name, and now we're stuck with it. So if somebody has a better name, come with it. Here we have an interesting way of comparing with RAG and without RAG. So on the left-hand side, you have a base model without RAG, and the right-hand side, you have a RAG fine-tuned model. So what we're asking here is, what are the risks associated to FTX? So FTX is cryptocurrency exchange. You know that since 2022 is bankrupt. So if you are having a cutoff date in 2021 on the left, there's information that's missing, and it's maybe giving answers that are, yes, it's interesting, maybe there's some risk. But if you're using RAG and you're using this information after 2022, you're getting much better answers and much more precise answers, and maybe it's going to say you don't invest in this. Are there questions till now, or is everything pretty clear for you guys? Then I would say we can start.
There was one question here.
There's one question, yes.
And maybe you can give your name and your question to everybody.
Hi, my name is Falco. Can you get one slide back? I just wanted to ask, now you apply both, right? The fine-tuned model with a RAG?
Yes.
Okay.
Yes.
Yeah.
Yes. That's it. There's a question here.
Yes.
Hey, my name is Lucas. I have a question regarding the performance. What is more performant if you take the data and train the model on, or do you use the data for RAG purposes? If you could compare those or benchmark those, what would be better to do?
You mean, yes, here.
Now, normally you're not going for performance, you're going for improving the results. So that's the reason why you're doing a fine-tuning. And the gold standard is fine-tuning in combination with retrieval augmentation generation pipeline. But there are also more advanced techniques to get around fine-tuning a full large LLM, like using an adapter architecture, which is then just using a layer of fine-tuned weights on top of the regular fine-tuned model. So this is something which is emergent, and pretty sure we will see some nice little improvements in the future around this.
Thank you. So I have now an interesting way of showing you retrieval augmented generation. And what I'm going to try to show you is that you can see the difference between a base model and a base model with RAG, where I can augment the generation of text from retrieved text retrieval, and this is augmented generation. So in the slides, I'm basically going to show one without retrieval and one with retrieval and compare both. So we're starting here with a user. You have a user and a chat model here. And the user asks the model a question. This is not the only way to use large language models. You can also do summarization, or you can do translation. But in this example, we're just having this chat model here. So in this case, we're trying to answer a question. You see here the question: what is the world's fastest supercomputer? And the answer, of course, depends on the sort of response you're getting from the chat model. I think I'm going to stay here. So you're going to additionally add a system prompt. So we're talking about this. This is this coaching prompt in the config, and you're going to wrap it around it. And this is going to be something like you are an assistant tasked with answering thoughtfully. And if you don't know the answer, don't say you don't know it. So this is kind of the first step we're making here. And you have, of course, cutoff dates, as I was saying that. 2021, you're having a cutoff date, June 2021. So you have those most open source models like Llama 2, like Falcon, MPT, Open Assistant. They all are trained on old training data. That means these LLMs are based on open source public data sets with common crawl and the pile with catalogs, okay? The purpose is to make the model understand English and another language with this information. So it's not giving the right answers, but it's more giving him the possibility to read different languages. So as you can see, in this situation, he is answering as of June 2021. He's giving this answer. And the problem is, of course, you are not having the right, let's say, answer here, talking about this question you're having here. So what can the developers kind of control on here? Trying to put on the different points. So the developers can control what the chat model can choose. They can use the model parameters like temperature, sampling. These are a way to control the creativity of the model versus the repeatability of the model. Then you have the second point. This is the prompt engineering part we're talking about. This is something the developer can kind of do. He can say exactly what the model should do if there's maybe an answer that he can't also answer. Then the third point is something we see lots. It's using rules to process the queries. In other words, it's something like this personal identifiable information. So we're talking about confidential company data. In some of those cases, developers are making frameworks and guardrails to be able to get those valid questions, to be sure that not data is going into a public model, and to keep like this personal data in their own data centers. And fourth is how the responses are displayed in the UI. And if you have multiple queries, having the chat history too, and displaying a picture of the documentation link. So this is the first thing if we're talking without retrieval. Now we're going to make the step more, because if you add the retrieval, there's a lot of things that are going to change now. first you must run a sort of a vector database. So you see it's just here. Also having Weaviate here. So he's going to talk about that after. And what you're going to do is you're going to build this vector database, a place to store the knowledge database of the company, okay? That you, so this knowledge that you're retrieving from. And obviously what you need is materials, so external materials from the internal knowledge database that you add to your database. The first thing what you're going to do with these documents is that you're going to prep them, chunk them in texts, and you try to split them in a sentence-based way with paragraphs. You're going to make sure you have headers with a certain format. You're going to split HTML web pages, headers, characters. You're going to maybe have PDFs you need to split around, and you're going to try to make a new format. Maybe you have OCR documents and chunk it up with different strategies here. Then you need to separate the model with often the same architecture as this chat model. The purpose is to convert these chunks into embeddings. The immediate step here is to go from characters that are human readable to tokens, which is how a model understands in which encoded way it's represented in different words in the English language. You can call that, you can name that tokenization. Then those tokens are converted in embeddings, which is basically the way to have a spatial representation of all that information. That is done in basically a similar relationship in spaces between the English language to understand the semantic. So the semantic is, of course, let's say if you take a bus, a car, and a truck, it's pretty similar, but it's not similar to a dog, for example. So this is also done in Google. So we search through this vector database that is this kind of knowledge database that we have been building now. Without using key weights before, we use the service prompt here on this side. And what we said before is if you don't know the answer, just say you didn't know it. But now with this prompt, we're going to say here, use these 3 following pieces of information from the vector database. That means that you are going to add or you're going to change this vector database, and the prompt will include the information about the 3 pieces of information from the vector database. The prompt engineering will now add the retrieval from the database. So you're adding intelligence or smartness to your model here. That means, so now instead of saying, of asking what information do you have, and he says, well, as of June 2021, now you don't have a cutoff date, and you have the right link to the right document here. So the answer to what is world's fastest computer here is going to be Frontier, and it's going to be now a link that says Frontier at National Lab is the #1 supercomputer and top 500 because the data has been prepped correctly, and it gives the right answer here.
There is one question
Yes,
in the
for
audience,
sure.
if you want to take it.
Thank you. I'm Vollet, and I have a small question. How is the model made aware of the presence of the database so it knows that it now can retrieve?
It's here in the prompt. We're saying in the prompt that he should look at 3 parts and integrate this into it.
I'm like more technically, how is the vector database is connected to the model itself? Like, yeah, what is the channel by which they are connected to each other, and how? Because, yeah, how does LLM can retrieve information from somewhere?
context window. So you have stored information in vector embeddings in the vector DB. Then you can do a hybrid search depending on the vector DB you're choosing, which is traditional text search BM25 combined with vector search. And in the vector database we are talking here about the model horizon. So there is a knowledge cut after a specific date, and you want a response which is generating an output based on data or facts which are happening after these knowledge cutoff the large language model is trained on. And what you're going to do is a retrieval, traditional information retrieval in the vector database, because the vector database has the vectorized information, what happened after this knowledge gap or any new information you have added to, you want to add to this model. You do the retrieval, collecting these chunks which are related to your hybrid search, to this question, and then you're using these chunks and information and you're putting it into the context window of the large language model. And this way, the large language model can generate an output which is based on the stuff the model is trained on, including the new information.
Yes, another question?
Silvio has a loud voice. But
It's okay, thanks. Silvio is my name. So basically, your answer, if the search engine sucks, you're screwed or not. I mean, that's it.
Not gonna lie, if the retrieval sucks, and there are many, many ways how you can screw the system, but there are also many, many ways to improve the retrieval, improve the REC overall. And the good part is was a good choice to come early up at 9 being here, because we will talk about some advanced REC techniques improving your retrieval. But definitely, if you're putting unnecessary stuff into the context window for the large language model, it's generating you fuzzy stuff, which is maybe not giving you the information you're looking for. And information retrieval is not new to working with large language model. It's a discipline which it's old. It's over 10 years in the field. And some of the techniques you're using now in combination with large language models are old stuff, which is now getting a revival because it's about information retrieval. And a more precise information retrieval comes at computation cost. If you're using a transformer model, for example, to retrieve information, it comes at a higher computational cost at just doing text search, for example. But this is also the magic of using something which is doing hybrid search out of the box, because you combine both best worlds together, and then there is some kind of re-ranking happening. So we will have some examples later, which is talking about re-ranking in Weaviate, using a transformer model for re-ranking like the ones from Cohere. Yeah.
Thank you. So it's important to maybe also see what data you're using, what AI workflow you're having here, and understanding maybe what embedding works best for this, and also look at best practices. That can also help. So I'm trying to put on now the what the developers can really control. So if we compare it to without retrieval, we can do with retrieval, we can do also what we can do without retrieval. Plus, number one, you can control what the company documents are and what combination you want of, let's say, public data, of your internal data, and you can make a very good mix here to have the best kind of rack experience. Then you can have the way which you prep the data in chunks. So you have different ways of doing this. And as you were saying before, there are different ways, different strategies. So here you need to make a good choice. Then number three, you can say which embedding model I'm going to use. A lot of people use BERT. You have other APIs like Cohere that are also popular. You have fine-tuned models like SGPT models to build an embedding that is fine-tuned, specific sort of search or a specific sort of documentation. So you have choices here. Then the fourth thing is that the retrieval is done in this semantic kind of similarity, and you can use keywords. You can do this hybrid approach. So again, you have different possibilities here. Then number 5 is how the retrieval is used in a system. How many pieces of information am I going to use? Here I have 3. You can also use 5. It depends what you want to do here. And then the 6th point is which chat model is the chat model fine-tuned? How big is the context window? How can you, how important is this context window? How big should it be? And then the 7th point is concerning the response, how to display the users. Is there an opportunity to kind of provide links to the document from the retrieved information and help the user to understand how the response was built and see if it's really the right information he's getting for the answer? So you have different possibilities here. Again, I'm putting here without retrieval on the left, with retrieval on the right. And what we typically see is the people are starting in step number 1. They're just trying to make the stuff running. And that what we see then is they're going to use their data center and going to add their own data. And people are then going to step number 2 and having much better results because they're adding their external data. I brought you today also one of the cases we had at the Hannover Messe here. We've been doing this with RAG. We had a robot manual of 200-300 pages. You see up here number 1. What we did with it was make a RAG with it, embed it, make sure we have the embedding, the indexing of the manual. Then you're having here a question. I'm asking a question about the manual. So I'm one of the workers who's working with the robots. I'm just new, and I'm not sure how to change the battery and what model of battery it is to change the battery of the robot. So I'm going to ask here as a question. I'm going to say, where is the battery and how should I change it? And what is the model of the battery? So you're seeing with an API, we're using the Aleph Alpha model here. The large language model is a model that's called Luminous. It's from Heidelberg. And he is translating the question in an embedding question, trying to find out what is exactly the section where the answer is. Then you're having here, what's happening is he asking the question, having the right document, having these tasks here, and giving the final right answer and saying, you need to change the battery on the right of the robot, and the model of the battery is CX2530. So very quickly, you get an answer here. You're a new employee. This will help you to quickly change the battery and not need to go through these 200 pages. And that's really a good thing. And you can imagine where you can set up something like this. But this one is a pretty visual kind of nice use case we're having here. So that was my presentation till now. Are there questions on your side? I see on the back here.
I think you were first.
You have the same question.
Really? Okay, so my question is about what people use RAG for. Usually they say, bring your data, right? So it's like you don't want to, you want to enhance your prompt with data that's sort of IP. What happens if you augment a prompt, which is then sent to a provider such as OpenAI? The prompt is available to OpenAI in that case, which has the augmented part in, which is your data, right? So if you had IP and you augmented it and you sent the prompt over to OpenAI, they technically have that data, right? So do you have an opinion on whether or not that makes sense, especially if they say like, okay, this is your bring your data situation? data privacy, it doesn't seem to
Well,
be.
it's important to have guardrails here. Maybe you would like to.
So, and this is one thing which is super important for European-based startups, and one thing where we're seeing an emergent field of people switching or not using OpenAI because it's also by data governance not allowed for them that a third party is seeing these IP or these. I mean, if you're working with medical notes or patient data, or also if it's just personal data, it's not allowed for you to give in a third party access. And one way around this is using your own models in your own infrastructure. So you can spin up in VPC, which could be also hosted in the Azure cloud or AWS or Google in a European data center. And you have your own model in the loop, and then the data is not leaving the container of your own infrastructure. So you're doing some parts of these in-house. But this comes also at the trade-off that you cannot use a cloud provider who is sitting exclusive in the US, like OpenAI, so you have to switch and choose. But there are also regularities, or at least you can opt in on the OpenAI side that they're saying, okay, we are not using your internal information. But we have seen companies moving away from OpenAI because to some degree they're using the user input also to train their models. So they're collecting the data. And if an IP is important for your company because that's their evaluation or how they make money, you should choose an architecture which is not giving away your internal data. Otherwise, you're losing your mode.
And what you want as a company is you want to also have a stable kind of answers to your questions. And if you're also using an API, maybe they change the model and you're having maybe other answers coming in. So what we also see is that people try to get the LLM on-prem, to use their data that's air-gapped, and try to build the use cases on-prem and have the power on their own RAG, on their own LLMs, to be sure that you have a stability here.
Nico, my name. Hi, thanks for the talk.
Hi.
What is the trade-off, in your point of view, between using RAG or putting all the information in context if possible? I mean, context lengths get bigger and bigger with recent models. Your 200 pages manual might at some point fit into the prompt altogether. So no need to find the section that is interesting for the user's question. But maybe it's too much information to really grasp the question or for the model. I don't know. What's your experience? Is it better to put as much as possible information into the prompt, or rather use RAG to find really a short snippet of information?
I understand what you're meaning. It's also depends of the costs again. What do you want to invest? But you're having much precise answers if you're using this RAG possibility, and otherwise you need to make a very long prompt to kind of have the right answer, I would say. Do you have another?
So some months ago, we were still in these, these context windows are getting bigger and bigger. So Anthropic with Cloud was one of the first having these extra large context window. And one of the problems they were facing was these long tail problems. So the LLM was generate or highly focused on the part in the middle and was ignoring stuff in the beginning, but also giving a higher weight to the stuff at the end. But this is solved. So seeing at the new benchmarks, this long tail context window problem is solved. And at the moment, we are doing a POC with Google Gemini, which is also having a super large context window. And then it's depending on the use case and the data you're throwing in. So sometimes it's better to have a retrieval using these advanced retrieval techniques to just fill in the relevant data to the context window instead of all the pages. But sometimes it's just enough to use these extra large context window, depending on the use case. And I know, one story from the front line, I know that OpenAI is trying to build their stack exclusive around getting rid of something between. So, but this is, I mean, this industry is moving super fast and it's changing every week. I'm not counting in month. So let's see where we are going, but we are seeing at Weaviate an emergent or more and more adoption around real RAG pipelines, also companies which are using Claude or now doing a POC with Gemini with these large context windows. But I cannot tell you where we are in half a year or next year.
Hi. Here. I just want to add on to the discussion with OpenAI and data security. Two comments, because it's been said that OpenAI is only accessible from the US in US American data centers, which is only partly true because you have the opportunity to start your own or create your own endpoint via Azure. And Azure now provides endpoints in Sweden, France, and Germany as well. So this would be one way to go around. And the second part is really think about, like, if you want to create your own open source model instead of using one of the, let's say, APIs of the big players, it can be super costly. And so I would really tell you to think about what's the development of the big players there. As they are now moving already to Europe, it's you can wait a little longer, I feel. That's it.
Thank you very much. It's always a question also, how private is your data? How important are the security points you need to cover? And that are really important points. I see another question here.
There was also a question here, quick one from Jan.
You need to answer, I guess. You want? Okay, I'll just go quick. It's not necessarily a RAG question, but mostly about embeddings. We're working on evaluating LLMs and evaluating the output that was generated by LLMs. And one idea that's out there is you can use Rogue as a metric, but we're considering using embeddings also for similarity search. And then, you know, if you have an output of a text and it's semantically in the same embedding space enough, then we could count it as a true statement, basically. If it's too far out after a certain threshold, it would be a wrong statement. Do you have any experience with that? I can just share our experience. So for our experience, it just doesn't really work so well. And we're wondering if it makes sense to add RAG to the embeddings that we're having, if it makes sense to use a difference score basically for evaluations, or if you have any sort of experience with using embeddings to compare similar text output, which is semantically, let's say, similar, to automatically evaluate it, that would be helpful.
The experience is that we are working with HP with Generative AI Studio, where you can compare different models, very easy to compare them, and you can see which kind of way of embedding of RAG works the best with your data set. We're using that also with Hugging Face, so you have a possibility to take LLMs and then to see that. So if you want, we can discuss about that. Do you have something additional?
In the end, it's depending on the data you're throwing in. But one solution which could improve your similarity comparison is already at the chunking level. We will see an example later on, is doing it on sentence level. So not by tokens, by sentence. So this way, you're storing full sentence and you're comparing these to what you're throwing in. And there are additional, more advanced techniques, also in combination with a vector database, because you can store multi-embeddings. So you're storing your on a sentence level, then you can create a context-aware summary related to this sentence, which is improving the retrieval and maybe helping you comparing the right stuff to do the similarity comparison. And another technique is using some kind of entropy in addition. So you're throwing in what's before the token and after the token also in the embedding. This is increasing the overall size for sure, but you're getting, depending on the data set you're throwing in, a better result. Let me think about. Another technique could be using an LLM in the loop to create variations of these sentences and also store them and using them for the comparison. And maybe we are exploring some more advanced techniques later.
One question here, right?
I have a question on structured data. So let's say in the example with the battery, you also need to include where is it stored, its location, price, how much is in the stock. Does it make sense to have it as part of the rack system, or would you fetch it separately and try to include in the prompt? And if so, how would you do that?
Wait a second, can you repeat because I missed the beginning?
The question is on the structured data. So RAG is, as far as I know, is good for unstructured text data. If you need to include, in the example with the battery, where you need to find the battery, let's say we want to find where it's located, the price of it, how much is in the stock, and that's stored in the database, maybe in various databases. So how would you do that? Would you use RAG for that? Yeah.
I would use RAG for it because there's another advanced technique. You're storing meta information so you're chunking your data and you store these price, maybe the year already as meta information, and then in the retrieval, because you can also use an NLM to generate the query for the retrieval, but it's not necessary because you can straight use this meta information as filter. So you're filtering on the year, you can filter on price range, whatever it is, and this is reducing the amount of data you need to search through and also improving the results of the retrieval. Because if you have 2022, 2021, but you're only interested in the data of 2021, then using this already as a preset filter is just giving you back information which is related to the year. Because sometimes text information in another year could be also found by this hybrid search result. But if you do the filtering, it's improving your retrieval.
Let's take one more question before we move on to Philip. Okay, your question, and then there's also an open Q&A later where you can ask your question.
Thank you. So the question is a RAG in that sense comparable to a Google search engine? The second question to it is semantic search in that sense here to stay, and people will fundamentally change in how to search something? And how much of the search of Google is already in the semantic mode?
Well, I think RAG is here to stay, and I think we're going to see even bigger advancements going on here. So I think this is the start where we're talking about with the RAG. I think there's like different things that are additionally coming to it to even make it more interesting. Not sure if I'm answering your question, but I think it's the start, and it makes absolutely sense to draw your data in to have a better answer. I think there's still one other question, no?
Yeah, quick one.
My question is more towards small and larger LLMs. So let's say 7 billion or plus models. Is there any kind of insights from you on using RAG for smaller LLMs or larger? What performs better in general? Do you have any experience there? Or did some tests, some benchmarking?
Also depending on the use case, because sometimes the smaller LLM is more performant because it's faster, and you can use the model architecture using a smaller LLM to improve the generation of the query or how to query the data in the proper way, because this is fine-tuned on your use case and also on the queries then generating, which you're using to fetch the data in the database. And then the generation of the answer is using a larger LLM. So this is a pretty common architecture you're using in a productive machine learning pipeline. But we have also seen use cases where people just using a T5 LLM, which is, I don't know, 1 billion parameters or so. Don't nail me on that, but way smaller than the larger ones. And For specific use case, this is good enough to produce the right output. But it's not that you can answer this, it's this and that. It's depending on the use case. And I mean, more precision using larger LLMs comes at computational cost and response time. So that's the reason why you're choosing maybe a smaller LLM to do stuff. But if the smaller LLM is highly fine-tuned on your use case, this could be already good enough to sail away with it and put it into production.
Thank you, Tjerk.
Okay, I'm Philip from Weaviate. One little thing before I started. So I learned yesterday at 4 at the coffee maker that we are switching from having a panel to presentations. So I'm recycling some of my old slides. And when I'm talking about old slides, this presentation was from January. But I also wanted to include the newest part. And I mean, 3 or 4 months in machine learning, at these times, it's like 7 years in normal world. I finished some of the slides on my way here to the campus this morning. So we are exploring some of this stuff together, and I try to give you the best overview I can about state-of-the-art retrieval augmentation generation. So first, this is Weaviate, and Weaviate is an open source vector database. Yeah, so you can use Weaviate for small little POCs or just tailoring, doing a POC. But the good part around Weaviate, it's super easy to use from your developer perspective because it's doing all the hard stuff, mostly in the back end and mostly not seeing from your perspective because you just have to fetch a GraphQL API. But it's also customizable. You can build whatever you want with these open source vector database, and you can use these completely free in your own infrastructure without Weaviate getting any money. So our monetization is if you're then in the need to scale Weaviate or scale your application horizontal, we are doing all the work for you in our WCS environment, which is Weaviate in the cloud. So shortly about me, I'm working in the field of IT for 15 years and in machine learning for 8 years because my team at KPMG was responsible for the natural language processing pipelines. And natural language processing at these times was not fancy transformer architectures. This was mostly rule-based and statistical machine learning. And we used Spatie. Anyone here knows Spatie for doing NLP? Good choice. I really love the framework. This was our starting point, building natural language processing pipelines, utilizing Spatie. And for a coincidence, the makers of Spatie then hired me as head of developer relations. And I took part of my team from KPMG to Explosion. Then also building NLP pipelines, but then new part was also included talking about what we are building, what you can do with Spatie, what you can do with Prodigy, which is the data annotation tool from Explosion to annotate machine learning data. From there, a short step into Gina, working with Scott. And from there to Weaviate. That's the last year. So Weaviate hired Edward and me, talking about Edward later, at the 8th of May. Yeah, and since then it's working on the forefront of AI, but also a crazy ride. I have some pictures of the last year, and I'm doing this for one reason, because I want to build here credibility. Why I'm the one who can teach you some nice RAG advanced techniques. The reason is at Weaviate, we are definitely at the forefront of this. This is my CEO, Bob, in his nice Gucci themed Adidas trench coat. And after seeing these I don't know how to frame this, but it was a very extroverted interview because he was sitting on a table giving an interview around Weaviate, and then Jewain thought we cannot get him away with it. We need to dress up after finding out, okay, maybe we're going for the cheaper option. And this is us in Las Vegas, Seattle. This is Clem, the CEO of Hugging Face. In San Francisco, Andrews, San Francisco. This is Aiden, the CEO of Cohere. This was in Vegas, I guess. And this is my team, Victoria, Fiemke, Adam, Edward, Erica. This is at the campus. And I also had the picture of you, Nesrin, but I don't know. It's not there, by the way. So, yeah, so this is last year. The sad thing is that Bob likes to send my team and me around the world, and I'm not going to cry, but I hate jet lag. So this is the team, which is also, I mean, Weaviate enables me to work with these awesome human beings. And this is one of the things I'm most proud of. To some degree, this is also the extraction of my last 8 years working in AI, because Edward is on my side for 6 years, Victoria for 3 years, and our newest addition is Ajit. He's there. And from time to time, you see Edward, Victoria, Ajit, or me here at the campus. Adam is working in San Francisco, Femke in Barcelona, and Leonie is working in Frankfurt. So this is what my team is doing. So beside building these workflows, also making sure that people are aware what you can build with Weaviate. Here I'm going, because it's an old presentation, I'm just skipping, I'm just covering short part. This is around horizontal scaling and why you should choose Weaviate. This is about multi-tenancy, so that you have real data isolation, which is exclusive at the moment to some degree for Weaviate. Also other vector databases have implementations around this, but I truly believe this is the best multi-tenancy implementation, but not talking too much about it because we are here to talk about RAG. Yeah, product quantization, which is saving you, I mean, the trade-off is precision to saving data, to store data. But now let's talk about RAG, Retrieval Augmented Generation pipelines. Realizing yesterday, okay, I have to prep a talk. I'm just stealing, or not stealing, I'm reusing the content from Leonie, from my team. She's, besides working at Weaviate, she's a Kaggle notebook grandmaster. And she has a lot of stuff around retrieval, augmentation generation pipelines. And the interesting part is advanced RAG. She's making a separation between stuff you do on a pre-retrieve. So on the chunking level, there's nothing hand over to an LLM generating an output. It's when you're feeding in the data into the vector database, that's pre-retrieval. Then the information retrieval and post-retrieval, stuff like re-ranking. And we will cover all these techniques on the next slides. So there's stuff you can do before, then on the retrieval side and after the retrieval. That's the separation here. And one of the techniques you can use pre-retrieval is, we already talked today about this chunking overlap. So you're using this entropy, you store more information, but this is helping later the retrieval to get the right information, because there's a high probability that these chunks, which are before and after, also including information which could help improving the retrieval. Does anyone have an idea why this is the case?
So I think we chunk. So essentially when we retrieve, that the model knows in the context window that the parts belong together. Why? Because essentially it can combine the information which has a surplus.
Yeah, to some degree.
I'm just taking a guess now. I'm assuming that if you chunk and the chunk is too small, you might be missing information when you take the top K or whatever, and you might be actually missing out on part of a sentence. So taking a little bit more might actually help, not cropping or clipping information when you retrieve it.
Yeah, also right. So, and one of the reasons, so, I mean, you can do the chunking on a sentence level, what we discussed earlier today, but one of the main reasons why this could improve the retrieval and also later on the generation, most of the time language is connected, linear. So stuff which is happening before and after, there's a high probability that this is also related to the chunk, the sentence you're looking for. And adding this later to the LLM or using it for the retrieval could improve your results. But this is also not a linear thing, that there's a break even. And sometimes it's also then, if it's too long or you're using the wrong parameters, it's worsening your results. So you have to test. Also something we discussed earlier on, using at the chunking time, generating meta information. And this is the example. So you're storing meta information for later on filtering. And for these questions, I'm only interested in stuff which happened in the year 2021. And through storing this meta information and then filtering, I only search through the pillar here. And this could also help, or this is improving the performance. So you're getting faster results because you have not searched through this pillar. And it's also helping you because also these data stores could include information which you're getting back when you're just doing a hybrid search over it, because it's looking for the similarity or semantic connected information. So filtering just information 2021 is improving your results. Exactly. So this is one of the charming things. Weaviate is doing this out of the box for you. You're just telling it on the chunking level, store this meta information, but it's also not exclusive to Weaviate. Also other vector databases are doing this. And a more advanced technique then for a RAG pipeline, and this is a pretty advanced one, is self-querying retrieval. So that means the user is just handing in a natural language sentence, which is, I want red wine with fruity notes. And now imagine you have a filter, which is already filtering red and white wine. So you just have searched through a small proportion of the data. But the cool thing here is, I mean, I hate SQL statements. And I started as a data engineer, so you can feel my pain. But the cool thing is that we are using this natural language and then using an LLM to generate the query, including the filter. So no SQL statement, no hard stuff, just using an LLM, generating the query, and then searching through a smaller data set, getting the right information. Another advanced query RAG technique is called RAG fusion. You have a user query, and then you're generating with an LLM similar queries, not similar queries, queries which are following the LLM related to the parent query, but these are different queries. So you're generating 4 of them, adding the 5th one, which is the original query, then using this, fetching the data, and then you do reciprocal rank fusion. That's the name of the technique. You have to re-rank because you get for all the queries the results, and then you have 5 lists, which you need then to combine to one list with this re-ranking, and then you may be getting the top 5, the top 3, whatever it is. And based on that, you're generating the output, and this could also improve the retrieval, and the generation. Yeah.
Yeah, very interesting technique. Maybe one short question regarding this whole machine. So I mean, ideally, it would have 100% precision and 100% recall. And then I believe you, it all works nicely. If it screws up on recall, then you lost that document anyway. You can't say anything about it. So that's the thing you really don't want. But how does your generative output look like, or what's the robustness against bad precision? Because if you optimize for recall, you might lose precision. Can you say anything about that?
As always, I mean, 100%, not many times. Often it's you're making, I mean, it's like you're trying to get the best possible results based on the user input. And sometimes, I mean, the user can also mess up what the input here is, and then also these generated queries are not helpful. And in the end, it's an estimation. You're not getting these 100%. And it's always a trade-off between precision and performance. And also, as said, I mean, it's a search. Like you can create a search query which is not useful or not leading to the information you're looking for. But this is also the reason why you have to test your application, also having, however you want to do this, benchmarking, testing with a test data set, and then it's optimizing on the go. Was this the answer? Or, I mean, there's not much you can do when you're screwing up already the search.
I mean, if you have all the right documents, but a lot more garbage, is there anything you can do at the level of the generative output to still provide the right results?
Now, this is depending on the retrieval, because you're searching for the right information, which is related to the user query, and then you're just using this information and hopefully not all these not necessary garbage information. And what you can also do is, I mean, if you're aware of which use case you're using, you can already fine-tune the generating model on a specific use case, which is then hopefully generating better answers, also which maybe not all the information necessary, because it's already fine-tuned to some degrees on your domain, for example. But this is machine learning. In the end, 100% not, but also if you're asking a human, you're not getting 100%. So another more advanced technique to improve the RAG pipeline is query splitting. Because sometimes language can be complicated, and then using this query with maybe 2 or more entities which are also related to each other, it could make sense to split these up. So what is a vector database? You can split these up into what is a vector, what is a database, and this retrieval is easier to understand for an information retrieval, and it's giving you the information back, what is a database, what is a vector, and then you're putting both things in the context window and using in-context learning. So also if, I mean, most of the time the LLM is aware what is a vector or what is a database, what is a vector. But then you're handing in both information pieces and let the LLM generate the answer. But there's a use case where it was around Google Gemini, where they did these in-context learning. So there is all this, the LLM has seen a lot of information around language and how language is structured, and also these different kinds of roots of language. And then adding information about a new language the model has never seen in the context window was enough for the model to generate proper output in a language it was not trained on. It's called in-context learning. Going from query splitting to also doing here a query splitting, because compare the revenue growth of Uber and Lyft in 2021, and then you're splitting these up for Lyft and Uber, and this could also improve your performance because you can do at the same time 2 searches in everything related to Uber, everything related to Lyft. You're also using this filtering, and this is depending on your infrastructure and how you parallelize this, but this, if you're using the right architecture, is improving your performance because you're doing it at the same time and then getting a faster response. Retrieve window of chunks. We talked about this entropy at the chunking level, and now it's about, this is for the generation. So I'm doing a retrieval on just this piece here. This sentence is the original information, but this is the information which is before the stuff I retrieve and after. And I'm adding this to the context window because there's, as said, a high probability that this information is, and this information is adding maybe something to this part here, because just of the structure, how language is structured. So the LLM is not just seeing what you're getting back from your retrieval, you're adding the stuff before and after, putting this in a context window, and this could help improving the generation. But also it's a case-by-case thing you have to do. So not always the information before and after is adding value, because it's not always, you can talk here about completely different things which are not related to this. So this could help improve, but as said, it's a case by case. Semantic caching. So this is a technique which is inbuilt into Weaviate. So looking at these two sentences, what is a vector database? How do a vector database work? To some degree, what you're getting back could be mostly similar. Not the same, but mostly similar, because how a vector database works is including a lot of information what a vector database is to some degree. And to save computational cost, and also if you're generating an output from a user, so you have the full pipeline, retrieval, context window, and then the generation, you can store this in some kind of a cache. And if the user is asking the same questions, you do not need to do all the stuff. You're just using the cache, and it's there in a millisecond. But the question could be on a semantic level, it could be different. So from the wording, it could be different what it is, but the semantic relationship is the same. And this is what we're seeing here. So there's a threshold where you can influence the threshold, and depending on how you set this threshold, this is maybe the same thing you're putting into the context window. So you're putting the same stuff what a vector database is when the user is asking how do a vector database work, same stuff into the context window. In the user prompt, it's still about what is a vector database, and then it's generating the answer based on this, but seeing also in the prompt what the question was, so the LLM can relate and generate the right output for this question. Another technique to improve the retrieval is on when you're generating the chunks or the vector embeddings, you can store a summary of the document you store in the vector database, and you can do this context aware. So if I know what domain is I'm operating in, it's the medical domain, I can always at chunking, at vectorized time say, okay, save me a summary which is related to the medical domain, and maybe it's around pharmacotherapies, and you can add additional information to save then a summary in the context of pharmacotherapies around the medical data set, and using this summary for the retrieval, which is improving performance, but also can improve precision for the retrieval. Another technique is using the history. So if a user is chatting with a chatbot, it could be, but also not scales linear, that the information before has something to do with the question, because the user is not getting the information he's looking for, but it could help the LLM to understand what was before to generate the right output. But as said, could also go wrong, because this could be totally different and not related to the next thing the user is typing in. Re-ranking. We talked about BM25, which is traditional text search, and getting from a semantic search your regular BM25 text search back and also your vector search, you can use a model in the loop with a transformer architecture to re-rank the results you're getting back. The problem here is that the transformer model comes at a higher computational cost. So this is most of the time slower. So but sometimes a pure text search could be good enough to give the user the right information. So doing a re-ranking comes at computational cost, but is something I have seen in many production pipelines, depending on the input. So you have a switch. Is the answer good enough? You do some kind of evaluation. If not, you're switching over to a re-ranking and hopefully improving the results. This is around Cohere's re-ranker model. So we are having an established model just using the Cohere re-ranker in the Weaviate pipeline. But a good thing is that Weaviate brings or already is doing a lot of the hard work around re-ranking. So this here is something which is unique to Weaviate. It's you combining the vector search with the text search and then doing a re-ranking compared on the scores, because the problem is when you're bringing the text search and the vector search together, the distribution could be totally different. So, and then doing a re-ranking based on both elements, depending on the data set, could be hard, but Weaviate is doing the hard work in the background, and you can also just set the right parameters or influence these results by the parameters. Then the Cohere re-ranker, then a re-ranker transformer model. Yeah, so from Weaviate perspective, this is just an API statement. Also, an emergent field is using agents for doing a RAG, because the user is querying, generating a query or the question, and the agent is making the decision which following part of the pipeline is the right thing to do. So because it could be that a RAG is the right thing to do, a full RAG pipeline, but it could be also that just using the semantic cache of a vector database is enough because there's a high similarity in the question and it was already answered. And this agent architecture helps you making these more modular. So you have an agent could be root, what is coming next in my pipeline, and also then helping with the results. So the output from this RAG and the output from the vector database could be combined, and then you have a new generation, which is hopefully improving your response. So a more advanced retrieval technique is using Colbert or Colbert and traditional text search. You have a knowledge base which is stored in a vector database, and the user is asking a question, and you're answering this question. You're doing a claim extraction. So what is the core essence? What does the user wants to know? Getting rid of all the unnecessary information, and then generating based on this a query or multiple queries. And now you're using traditional text search and Colbert, which is a BERT model based on transformers. But the good thing here is that the computational cost of Colbert is more or less than the regular transformer model because they optimize a lot of stuff. And most of the time, the Colbert model just needs to use 1% or 5% of the information. So it's super fast. It's a transformer model which is super fast because of the architecture and also includes re-ranking of what it's coming back. And then hopefully you're getting the right information back. DSPY. Anyone touched DSPY here in the room? Shukri. Tell us your experience. Come in front. That's Shukri. He's our solution engineer at Weaviate. And now I'm throwing him into the spotlight.
I regret coming. Yeah, so the SPY, I have a very good impression of it, and because it's basically frees you from doing prompt engineering. That's one thing. And the other thing is it allows you to program the steps you want your RAG to do, but using Python code. So for example, a classic example they have is when you want to do multi-hop querying. Do you have that? No. Yeah, chain of thought. If you look at the code, it's basically a bunch of if-else statement in Python code. So that's very cool, very easy to pick up. And then, yeah, then you can see also here optimize prompt. Recently, they added another component that you can write a very basic prompt, and then later you run the optimizer, and the optimizer will create a new prompt for you that will improve the performance. So yeah, I highly recommend people look into this.
Okay, so DSPY is some kind of a paradigm shift, how you build a pipeline working with an LLM, because Llama Index, LangChain, it's not right. So back in the days, this was mostly around using or templates for prompting, and you can change these kind of templates. And when you look at the code base of LangChain, a lot of this stuff is hard-coded. So it's just using a specific persona, a specific template, adding your information to this template, and then using it in the prompt. But what is the paradigm shift around DSPY? This is using prompt templates, and with DSPY, you're generating these kind of prompts, which are not just hard-coded, because the thing which is also used for generating this prompt, when we're looking here, so this would be the mostly hard-coded prompt, including your information, but the extraction of what this prompt is doing, context, question, and then generating the answer. So this is the signature. This is how DSPY is calling this. And you're using this signature in a chain of thought to generate this prompt. So not using this as a pre-existing prompt, you're generating the prompt out of the user information, including this kind of schema. So this is a kind of schema, how the prompt should be structured. Then you're getting this automatically generated prompt, and this is helping making your pipeline more robust for the future, because you're not using just a hard-coded prompt, you're using a thing which could adapt on the go. And also you can build several iterations of these, and DSPY is taking care on an evaluation level to improve the generation of this prompt and evaluating the output of the LLM. And they call this compiler. So this is then the prompt, and the compiler with some more information is generating the right prompt. And here the prompt is including maybe something you get back from a retrieval on a vector database, or something the user has put it in as question. And this is then used in the context window of the LLM to generate the right output. And the nice thing is that you're shifting away from these just hard-coded templates into a more programmatic way of working with an LLM. Okay, Verba. Verba is our production-ready retrieval augmentation generation chatbot powered by Weaviate. And we managed to get 2,000 GitHub stars. Pretty broad of Verba, and it's mainly Edward behind Verba. And we were building it at our time in San Francisco. So that's the overall architecture of Verba. So we have a front end which is written in XVS. Then we have several readers where you can ingest text, PDFs. We have also a GitHub reader. We are taking care about the right chunking, so that's nothing you need to do. And deciding on what the input or the data is, what is the right chunking technique. And we're using the old same NLP tricks we learned at Explosion. So it's also Llama Index and LangChain are using the same old NLP tricks to some degree. Then we have the embedding manager, which is handling the embedding model, which could be a sentence transformer, OpenAI, Cohere, whatever. then all these nice little retrieve tricks, or some of them, are already included in Verber. And then how we generate the output. It could be a Llama model, open source, or GPT-3, GPT-4, whatever it is. Yes.
Question about the OpenAI ADA, advanced data analysis, right in the middle. Yeah, so I noticed that you have that I haven't really seen it in other applications before, meaning the ability to analyze data, like structured data, and maybe even around pieces of code. So is that like common, or is it something a bit unique?
You mean around Verber or in general?
In general, because usually when I see RAGs, it's usually working on texts or, but ADA is the data analysis tool is something different. It works analyzing structured data, typically numerical data. So I was wondering, like, if that's something like a different category of inputs for this kind of tools.
Now, the good thing here is, as it's modular, you can put here the right data reader or data ingester, but you can also just use the data ingestion from Llama Index, LangChain, to store this information in Weaviate. And you can hand in JSON, CSV, and then depending what you're choosing, it could be also saved a clear representation of this JSON file. But this is a bit depending, because you can also declare the data type of this JSON field or this CSV, and then store the clear information in Weaviate. But this is depending on your use case.
Okay, thanks.
So this is Verber in action, but I have also a live demo. What's the hotkey to leave my full screen? Because I'm not using the full screen so much. What? Command F? I had these, but Ziv wanted me to enter the full screen mode. Now I'm regretting it. So we have Control F. But I also remember it was something with F. Let me out. I'm Googling. I'm giving up. Command Shift. So Command Shift. Nice. No, it's working. So this is Verber in live. And I was testing, so how to use AutoCAD, but we can do it again. So, and now we have a retrieval with this. So what is Verber? So we use Verber enabling people building with Weaviate. So we have our internal knowledge base around, this is the documentation of Weaviate. These are our YouTube videos as transcript. These are everything we have created around Weaviate. We're ingesting this to the vector database. Now we're doing this retrieval. But let me reload the page. And now I'm asking as a user how to use AutoCAD. So it's now doing the retrieval and already giving me the sources back. So this here is a source, the result of a hybrid search around our internal knowledge base. But the cool thing is that this part here on the right side is generated by the LLM. So this is using the information or the right chunks it's founding in the source documents, putting this into the context window of a large language model, and then generating this kind of information. And we can also search other stuff. Because I want to show you one cool thing. Let's see if it's work. Because we are also handing in parts of our code base, and the LLM is generating the right output, because most of the time an LLM is trained on all the open source available software. And if you have an identical kind of style for querying or for using your code, sometimes the LLM is mixing this up because you have seen this at training time, but your internal API or your internal functions are quite a bit different. And then using your own code base to make the LLM generating this query here could help that the user just have to copy paste this and can use it in their production pipeline. So Verba. Yeah, you can play around with Weaviate also on Replit. Health search, also cool stuff. So health search is our hybrid search demo showcase. And this is a thing we built years ago and just recycled it for Weaviate, because this was originally a pharmaco pipeline around patient notes for adverse and positive drugs effects. So a patient is talking with a doctor. This medication has helped my migraines. This medication has helped my depression. Or I have these and that adverse drugs effects. And we were rebuilding this pipeline at Weaviate with the new stack. So using a large language model in the loop and Weaviate with hybrid search. And the original pipeline using traditional NLP stuff, which were costing us 3 months. And we rebuilt this in just a week at Weaviate. But also Edward and me learning how Weaviate is working, because we were just in. So the cool thing is here, when I'm looking up, so we changed the data set to a supplement data set so that it's more accessible. And what we are doing is generating this GraphQL query with a large language model to fetch Weaviate. So the user is entering natural language, and out of this natural language, we're generating a GraphQL query to fetch the right data. And then we're using these supplement reviews and generating, so one overall compression around what is helpful for joint pain here. Yeah, we have more stuff, also a demo application around Magic the Gathering, but that's all. Now we have a Q&A.
As we're quite over time, let's take a quick 3-4 questions, and then we open up the networking for more questions.
First of all, thank you very much for your talk. It was very interesting. I have a talk which is related to more like, what would you recommend? For example, I have a database which is comprised of text, which is heavily like mathematical, a lot of equations, a lot of figures. Which techniques of RAG would you recommend for me to create this retrieval augmented pipeline so that I can then query data and use LLMs on it to answer also questions that, for example, relate to equations which are generally in LaTeX, so it's not like pure natural language. That's a bit different, but still, yeah. What would you recommend for that?
But they're in LaTeX, right?
What?
LaTeX.
Yeah.
So now the good thing here, I mean, there are 2 answers to your question. One of them is using the visual representation and then using some kind of OCR. But the LaTeX representation is already a representation of what is happening on a mathematical level. And this representation or abstraction is something the large language model has already learned, because it has seen enough LaTeX equations with the results. So you can easily use these to generate you the right answer for this kind of stuff. But if you're not having this LaTeX representation, you could use some kind of OCR and using a model which is multimodal and just asking the model to generate the LaTeX out of this visual representation.
Thanks so much for the talk. I have one question regarding code competitions in general. You mentioned that one of your team members was a Kaggle Grandmaster, notebook Grandmaster, if I recall correctly. Have you seen any code competitions regarding or where racks in general are included? And can you give us some insight there how the community, especially leading grandmasters, are using those tooling to enhance their scores on the leaderboard?
Yes, let me. I need to remember because we created a notebook for a Kaggle competition using Weaviate for rec, but I need to look it up. So yes, it's happening. So yeah, easy. It's also created by Leonie and should be 19 days ago. Yeah, so we're using Google Gemini, Weaviate, and Llama Index for an advanced rec pipeline in a Kaggle competition, but this is Leonie. We're thinking about pushing this a bit more or creating more, enable Kagglers to use more advanced rec stuff based on Weaviate. So this is something we're currently thinking about.
Yeah, thanks so much for this presentation. I have a question actually related to exactly what you mentioned right now. So these are a lot of techniques, and if I wanted to try this out for my own project, it would probably take me a lot of time to implement each one of them. And my question is there like an abstraction layer or some RAG engine? Maybe you already have this, I mean, besides Verba, which is like an example of such implementation, but if I want to implement this for my project, I could just like automatically run some experiments with different RAG techniques super easily, something like maybe like sklearn pipelines or something. And I would run some automated experimentation and then try to find out what is the combination of RAG techniques that works best for my project. Do you know of like any way to do that?
Llama Index is already delivering you a lot of stuff for evaluation and also for comparing these different stuff of querying for the information retrieval. But I'm not aware for a solution which is working out of the box, including all of this. So it's all of them, including that you have to adapt this to your own use case. But I have seen a lot of these kind of pipelines coming from Llama Index. I would also think so that that LangChain also have a library or at least best practice to do this.
Okay. Question here, right? You?
Hi, thanks for the presentation. It's very interesting. I was wondering, you mentioned PEFT briefly before, and I was wondering, are there use cases where it's clearly more useful to use PEFT above re-ranking? Or yeah, what's your opinion?
It depends, of course, what data you're kind of using and how precise you want to be. Mostly, it's really in between. So people are working themselves up from, as I was saying, prompting, then RAG. And if they see it's not good enough, then they're taking one step more. But people are more staying at RAG because they're seeing it's working well. I have one or two cases that I know where we're using PEFT.
So it would even be like possible to combine them, right? Yeah.
There's one here in the back.
Hi, I'm Niels. I'm already hooked to give Weaviate a try. However, I was wondering if it's also possible to use, or if you provide tools that could be used purely on-prem, or if it's more cloud centered.
You can use Weaviate completely on your own infrastructure, on your own computer. So the full Weaviate is open source. The cloud offering is come into place if you want to scale these without the friction. But you could also scale these with Kubernetes on your own infrastructure, completely in your own container. There's no connection to Weaviate. It's real open source. So it's not half open source, it's real open source.
Thanks.
One more question, and then I think we should go to networking.
Thank you so much for this very nice presentation. It was very helpful. So my question is, imagine that I have a textual record of 10 team members, right? And it's about their biodata and their history, where they have worked or something like this, right? And now my query is how many team members I have in my team. So how the semantic search or Weaviate or KrumaDB, they are going to handle this query. Thank you.
If the information you're querying is just including this information, you're getting results back with hybrid search, which are highly not helping you answering the question, because you're doing the retrieval over data, which is not helpful in this case. What you can do is having something in the loop which is evaluating the output. Could be also an LLM. Is this related to the question? Is this really answering the question? But you can also introduce a threshold. So first, just looking on a vector level for similarity, maybe yes or no. Maybe it's hitting. If not, using the more at higher computational cost LLM to check, is this really answering the question? If not, then shut up. So Verber has this kind of implementation, because otherwise the user is getting an output which is not helping him and maybe routing him in the wrong direction. So it's checking, wait a second, is this really something which is useful as output? If not, sorry, I'm not aware.
Very nice. Thank you for all your questions. I think this is probably one of the most amount of questions we've had an event in a while. Let's open it up for networking, so you can attack the speakers with more of your questions. Please grab more breakfast. Your plates and bowls you can put in the gray box here. There's another Gen AI event tonight, so if you're feeling more inspired to come join us again this evening, please do. You can check it out. We have Spoke AI, DeepRec AI, Genova AI, and Cleverbridge. They're going to be talking about exploring AI applications. Thank you very much to you, Tjerk and Philip. It was a pleasure having you this morning. I hope you enjoyed it.